Okay, the Chapter 2 test study guide for Trig. Find the midpoint and the length of the line segment with endpoints 3, 1 and negative 2, 13. First off, if we do the midpoint, make it into two separate problems basically. The midpoint formula requires us to average the x-coordinates and average the y-coordinates. So if I'm looking for the x-coordinate of the midpoint, I'm just going to have it divided by 2, and I'm adding two numbers. The two numbers I'm going to add are the x-coordinate from the first point and the x-coordinate from the second point. And if I add them up and divide by 2, 3 plus negative 2 is 1, so the x-coordinate of my midpoint is 1/2. Similarly, to find the y-coordinate of the midpoint, same deal. I'm going to add the two numbers together, divide by 2. The two numbers I'm going to add together here are the y-coordinate from the first point and the y-coordinate from the second point. 1 plus 13 is 14. 14 over 2 is equal to 7. A midpoint is a point, it's a coordinate, so I'm going to write my answer as a coordinate. That's how to find the midpoint. As far as segment length is concerned, the distance formula requires me to have the square root of the sum of the squares of two numbers. The two numbers of which I'm talking about are going to be the difference in the x's. So how far apart x-coordinate 1 and x-coordinate 2 are. If I'm going from 3 to negative 2, 3 to 0 is 3 spaces, back to negative 2 is 2 more spaces, that's a total of 5 spaces. Looking at the second coordinate, the y-coordinate, we're going from 1 to 13, that's a distance of 12 spaces. So just a matter of figuring out how far apart those numbers are. If you can't figure it out just in the air like that, draw a number line. It's subtraction is all I'm doing. 3 minus negative 2, 13 minus 1. That's how you're getting these two numbers. And a minus negative becomes plus, that's why it's 5. 13 minus is 12. At this point, we're going to square, add, and if it happens to come out to a nice pretty number like 169, the square root of 169 is 13. If it doesn't, leave it as a radical. If you want to get a decimal approximation, your calculator can evaluate that for you. In this case, 13 is the right answer. Number 2, determine the x and y intercepts and then graph the equation x equals y squared minus 5. Starting off with the x-intercepts. To find any intercept, you let the other variable equal 0. So if I want to find the x-intercept, I'm going to let y equal 0. I go to my equation that says x equals y squared minus 5. That gets me an x-coordinate negative 5. So my x-intercept, there's only one of them here, negative 5 comma 0. I let y equal 0, that's where I got the 0 from, and we figured out that x equals negative 5. 1, 2, 3, 4, 5, 0. Point on the x-axis is what an x-intercept should be. As far as the y-intercept is concerned, okay, to find the y-intercept, we let x equal 0. So y-intercept, we're going to let x equal 0. If I go back up to the equation, x equals y squared minus 5, we change it to 0 equals y squared minus 5. That means that 5 is equal to y squared if I move the negative 5 to the left. And if y squared is equal to positive 5, that means y is going to equal plus or minus the square root of 5. Get a calculator out, type in the square root of 5. I get 2.24 approximately. If I'm plotting points, I want to get decimal approximations because decimals are easier to graph than square roots. So 2.24 is more useful to me in the sense that I need to use it here than the square root symbol. The plus or minus is what a lot of you forget, so be careful that you don't forget the plus or minus. When it says letter squared equals number, you take the square root, you got to put the plus or minus on. Each of the points here is going to be 0 for x paired with the plus or minus 2.24 for y. So 0, 2.24 right about here, 0, negative 2.24 right about here. Next, it says to graph the equation. I've already plotted the 3 points I found. I can see very clearly that the x's here aren't being dealt with. What I would personally do though, seeing the equation the way it is, x equals y squared minus 5, we typically make x the independent variable and y the dependent variable. It's easier if you take the one that's being raised to the second power, make it be the independent variable. So looking at y, positive or negative 2.24 have happened and zeros happened, nothing else has happened. So I might want to pick 1 and 2 and 3 and negative 1, negative 2, negative 3. For y, then use the equation to solve for x, and that way I can get some points. If at y equals 1, 1 squared is 1, 1 minus 5 is negative 4. 2 squared is 4, minus 5 is negative 1. 3 squared is 9, minus 5 is positive 4. Negative 1 squared is positive 1, minus 5 is negative 4, seeing that these numbers match because 1 squared and negative 1 squared are the same. 2 squared, negative 2 squared are the same, so I get the same answer there. 3 squared, negative 3 squared are the same, I get the same answer there. These 6 points here, again, I picked the y's and I solved for x's. I'm still going to plot them in x, y order. So negative 4, 1, 1, 2, 3, 4, 1. And then looking at negative 4, negative 1, 1, 2, 3, 4, negative 1. I've got negative 1, 2, and negative 1, negative 2. Negative 1, 2, negative 1, negative 2. I've got positive 4, 3, and positive 4, negative 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. The graph is a parabola. It turns to the right, which we should expect since y is squared. It turns left to right, and it's positive in front of it, which makes it turn to the right. So some of the stuff we learned about parabolas here also come into play. What's left to do is connect the dots with a nice smooth curve. And there's our graph. On the test, expect it to be a parabola. Maybe it'll turn up or down instead of left or right. I don't know. It'll still be a question of x-intercepts, y-intercepts. If it turns up and down, chances are you have 2 x-intercepts and 1 y-intercept. Left and right, usually 1 x-intercept, 2 y-intercepts. Unless 0, 0 happens to be the only intercept, in which case that's what it is. It'll be of this type, so just practice your graphing skills. And again, whichever letter is to the first power, let that be the let that be the dependent variable, the one you're solving for. Let the one that's being raised to the power be the independent variable, the one you get to pick whatever you feel like picking. Number 3. Find the center and radius of the graph of the circle, x squared plus y squared minus 4x plus 6y plus 4 equals 0. Problem just like this on your last quiz. Some of you got it right very easily. Some of you seem to have some struggles with it. So let me just go through the whole process here, make sure that we all understand where it's coming from. First thing I want to do is I want to get everything containing x to be grouped together. So x squared minus 4x, I'm going to put it over here, leave a little bit of space. Then everything containing y is going to be grouped together. So it's plus y squared plus 6y, and again I left a little bit of space. Then I'm going to put an equal sign, leaving some space there also. And then any constants are going to move to the other side, and 4 moved across becomes negative 4. So first step, do some rearrangement, do some grouping of things. Everything x in front, gap. Everything y next, gap, equals whatever the constant is. That's step 1 of the process to find the standard form of the equation of the circle. Step 2 is to complete the square. We're going to have to find the magic number that goes here and here in order to make both of these, this here and this here, a perfect square trinomial. The magic number is exactly half the linear term squared. So half of 4 is 2, 2 squared is 4, so plus 4, plus 4. Add 4 on the left, add 4 on the right. I haven't changed the overall value of the equation. Everything is still legal. Half of 6 is 3, 3 squared is 9, so plus 9 here, plus 9 here. Okay. Modifications to the left have to match modifications to the right. You have to do both. Once we do this, the end result, this is now a perfect square trinomial that factors as a binomial squared. The square root of x squared is x, the square root of 4 is 2, and the sign of the middle term is negative. That's how you factor. Then you put a plus sign because you always put a plus sign. Then the second trinomial, parentheses squared, the square root of y squared is y, the square root of 9 is 3. This is positive, so we put a plus. Then we put equals, And then whatever these things add up to, we get down here. Negative 4 plus 9 is equal to 9. Those cancel, leaving 9. So that gets us to standard form. Once we get standard form, our job is to find the center. The center is these two numbers with opposite signs. So the x-coordinate is going to be positive 2. The y-coordinate is going to be negative 3. That's my center. The radius is going to be the square root of that number. So radius equals 3. That's what you're going to be asked to do on the test for a problem like that. It will have friendly, I'm going to keep these even numbers just to make it simpler as far as the completing the square process is concerned. Whether or not this comes out to be a perfect square or not, I don't know. Let's say this was 17, just put radius as the square root of 17 and be done with it. But square root of 9 equals 3, go ahead and evaluate it if it comes out to a nice pretty number like that. That's all I'm looking for on that problem, no graphing required. Number 4. Determine the domain of the function f of x equals negative square root of x squared minus 4. Domain is about restriction of functions. Square root functions restriction is that the radicand must be greater than or equal to 0. Okay, that would be the first step I'd expect to see on your paper. So those of you who got the wrong answer on the quiz, that didn't show adequate work. This would be adequate work. This would get you some points. Demonstrate to me that you understand the rule that's in place. If it was a rational function, stuff over stuff, and there's x's on the bottom, I would expect to see the stuff on the bottom is not allowed to equal 0. That would be a step that would show me that you have an understanding of the rule that you're using. What you'll notice about this specific one here is that this is a quadratic inequality, something we dealt with in chapter 1. And to solve a quadratic inequality, start off with equals 0. All right, so factor the quadratic expression, x squared minus 4 factors to x plus 2x minus 2. We find out values of x that make it equal 0. Negative 2 and positive 2 would make it equal 0. That takes care of the equal 0 part. Our goal is to find out every place where it's legal to have this function exist. So I'm going to start at negative infinity, go to negative 2. I'm going to put a bracket because there is an equals 2. I'm going to go from negative 2 to 2. Bracket that also because again there's an equals 2. And I'm going to go from 2 bracket up to infinity. Always parentheses on infinity. Then I pick my test points. Negative 3 lives in that region, 0 lives in that region, and positive 3 lives in that region. And what I'm evaluating is this expression here to see if it is greater than 0, also known as positive. So if I take that expression, negative 3 plus 2 is negative 1, negative 3 minus 2 is negative 5, 2 negatives multiply to make a positive. That region's legal because greater than 0. If I try 0, 0 plus 2 is positive 2, 0 minus 2 is negative 2, positive times negative gets me negative. That region's illegal because it would be less than 0. We're not allowed to get less than 0. And then finally for positive 3, 3 plus 2 is positive 5, 3 minus 2 is positive 1, positive times positive makes a positive. That region's also legal. So my domain in interval notation is that, and I'd be fine with you leaving it like that if you wish. Domain equals negative infinity comma negative 2 union with 2 comma infinity. If you would prefer to use set builder notation to represent the same domain, domain equals the set of all x's such that, okay, this one here is x is less than or equal to negative 2. This one here is x is greater than or equal to positive 2. So if you wanted to do set builder notation, that's how you do it. If you go with intervals, I want to see a union symbol demonstrating if there's multiple regions, this region union with that region. If you're going to go set builder notation, give me everything that's true here, comma, here, and so on. Separate the different regions with the commas there. Take your pick as to how you want to write that. I'm fine with both answers. Number 5, graph. Absolute value of x minus 3 minus 2. Identify the intervals over which the function is increasing, decreasing, or constant. So this is a two-parter. Part 2 is dependent upon the graph. So ignore this until you've graphed it. In this case, we're graphing an absolute value function. We've dealt with absolute value functions, linear functions, and quadratic functions in this chapter. So I'm going to stick to those types of functions. So it might be an absolute value function, it might be a quadratic, in which case the vertex formula negative b over 2a to find the x, pick numbers near it. It might be a linear function, use slope-intercept method of graphing. Everything you've learned is fair game as far as I'm concerned. So it's not necessarily going to be an absolute value function. If it is, fine. Absolute value function, the way you pick x, whatever this is, set it equal to 0. That's the x coordinate you want to have, and then you want to pick numbers around it, on both sides of it. So if I'm picking x equals 3, I want to pick numbers less than 3 and bigger than 3. So again, here's my magic number x, some numbers less than 3, some numbers bigger than 3, all numbers near 3. This is actually f of x. I'm going to change this y into an f and x. F of x. Alright. To evaluate f of x, I simply substitute these numbers 1, 2, 3, 4, and 5 into this expression. If we just come take a look at f of 1, it's going to be the absolute value of 1 minus 3 minus 2. That's the absolute value of negative 2 minus 2, which is just 2 minus 2, which equals 0. Okay. Evaluate, then make it positive, then add or subtract. For 2, same idea. 2 minus 3 is negative 1. The absolute value bars make it positive 1. 1 minus 2 is negative 1. If I try 3, 3 minus 3 is 0. Absolute value is 0, 0 minus 2 is negative 2. Try 4, 4 minus 3 is positive 1. The absolute value bars keep it positive 1. Minus 2 makes negative 1. 5 minus 3 is 2. Absolute value keeps it 2. 2 minus 2 is 0. Okay, just evaluate. So you pick x's based on some technique. Again, absolute value, what makes this 0? That's the magic x. Pick numbers near it. If it was a quadratic, x squared plus 2x plus 1, negative b over 2a, you get x equals negative 1 in that situation. Pick numbers around negative 1. 0, negative 2, positive 1, negative 3. Substitute, evaluate, get what you get. Alright, if I plot the 5 points I got, 1, 0 is right here, 2, negative 1, 3, negative 2, 4, negative 1, 5, 0. It creates this V shape, which is kind of what you're expecting in an absolute value graph. At the magic number, it should take a sharp turn, which it does. This graph is going this way, going that direction, and that way, going that direction. Okay, preferably use a straight edge when you're doing it on your test. If it is an absolute value, my lines aren't very straight there. But that's all an absolute value graph is going to typically look like. It might be more like this if there's a number being multiplied by it, or it could be like that if it's less than 1, whatever. But it's going to have this V shape to it. All right. As far as the second part, it says increasing, decreasing, and constant. Question's asking about intervals. Intervals begin at negative infinity and end at positive infinity. And they're all about x. They don't matter about y. Y is telling you, what matters about y is it's going up or down. It's increasing, going up, decreasing, going down, constant, staying flat. That's how y factors into it. The intervals we're listing, though, have to do with x. So looking at this graph from negative infinity all the way to right here at x equals 3, the graph is, if we're going this direction, we always go left to right when we're reading a graph, the graph is decreasing in size. So from negative infinity to 3, it's decreasing. Starting at 3, it starts increasing. Again, as we're going this direction, the graph's going up after 3. So all the way from 3 to infinity, it's increasing, and it's never constant. Okay, that's a possibility. It might not be constant. If it is constant, so be it. Then it's constant wherever it's constant. You know, constant would just be a horizontal line. So if at some point your graph looks like that, it's constant. This one doesn't look like that, so it isn't. Notice I didn't put brackets. The number at the turning point, I wouldn't count it wrong if you put brackets, but it's not really increasing or decreasing at that point. Number 6. And air freight companies determine that its cost per flight of delivering X parcels is this function. So this is the cost function. The price it charges to send a parcel is $10.60 per parcel. Okay, so the price is a set in stone price. every parcel costs $10.60 to send. Okay? So question A, the revenue function. The revenue function has been, every single time we've done revenue problems, has been how much we charge per item times how many items we're going to charge for. Okay, we're charging $10.60 per item. That's the price of one item. And we're going to be delivering X of them. So the revenue function in this problem is going to be $10.60 X. That's how you make a revenue function every single time. Price of one times how many we're going to send. Typically we're going to be sending X things. Okay? If the price were dependent upon how many we sent, like say they charge $10.60 minus 50 cents for every parcel they sent. Then the price is varying, so then this is going to have something about X in it times another X. All right, but in this case, one price, $10.60 per parcel, X parcels, revenue is that. Profit is, and always will be, cost, that's not right, revenue minus cost. How much we take in minus how much we spend. That's how you find profit every time. So for part B, the profit function is the revenue function we just determined, $10.60 X, minus the cost function, which is 920 plus 60X. Notice the cost function is a binomial, so make sure that we put that in parentheses. So we get the profit function here. If I distribute my minus sign through the parentheses, $10.60 X minus 920 plus 60 cents X. And notice then that the 1060 and 60 add together, so my profit function here is $11.20 X minus 920. Okay, there's my profit function, there's the answer to part B. Once we've established both the profit and the revenue functions, final question here. It asks us the minimum number of parcels that must be shipped to break even. All right, breaking even means we make no profit. We also lose no money, so we're looking for a profit of 0. So once we get our profit function, the break-even point is always profit equals 0. So $11.20 X minus 920 equals 0. That's how we find break even. Move the 920 over. That gives me $11.20 X equals 920. Oh, you know what? Dang it. Should have found that sooner. Let's go back in time. I missed that. So that's a plus sign there, which makes it a minus sign here, which makes it $10 X. Much nicer answer, actually. All right, so that's my profit function, 10x minus 920. Going back to part C then, breaking even means that we make no profit, so that means 10x minus 920 is equal to 0 profit. So therefore 10x equals 920, so x equals 92 parcels. If I sell less than 92 parcels, I'm going to be in the negative. Once I sell 92 parcels, I'm at 0. Anything more than 92 parcels is going to make me money. So that's kind of what we're looking for here with a profit function. What do we have to do in order to break even so that I know when I'm going to start making money? Be cautious that you don't do something like I did with the wrong sign there. Make sure you put things in properly so that when you distribute minus signs that things happen like they should. You get the right answers that way. Number 7. Find the maximum or minimum of f of x equals negative x squared plus 8x plus 2. State whether this value is a maximum or minimum. So, this is a quadratic function, x to the second power. So the quadratic function technique of finding a vertex, the x-coordinate of my vertex is always going to be the opposite of b over 2a. In the case of this specific problem, b is 8, so opposite would be negative 8. A is negative 1, so 2 times negative 1. Negative over negative makes a positive. 8 divided by 2 is 4. So the x-coordinate of my vertex is 4. So my vertex occurs at 4 comma something. The something is what I'm looking for. That's going to be the actual value that I'm looking for, is whatever the y-coordinate is. To do that, I simply have to do f of 4. F of x equals this function, negative x squared. The minus sign is not being squared, the x is. Plus 8x plus 2. We're letting x equal 4 because that's the x-coordinate of my vertex. And again, 4 is being squared, minus sign isn't. So 4 squared is 16, make it negative. 8 times 4 is 32. Negative 16 plus 32 is 16 plus 2 equals 18. So 4 comma 18 is my vertex. Now the vertex represents either the highest or lowest point when x is squared. Since x is squared, it goes either up or down. The way we make that determination is based specifically on this sign here. Negatives go down. So negative goes down, positive would go up. So it's negative x squared making it a downward turning, which means my vertex on this situation is the maximum point. It's the highest point of my parabola. So it's going to be find the maximum or minimum. I'm going to say maximum of 18. And so that's what we're looking for on a maximum or minimum value problem. What is it? And what is the actual value? And is it a minimum or maximum? Tell me that. Number 8. Let f of x equal 2x squared plus 2x and g of x equals 5x plus 4. It says find f plus g and f over g. That implies of x. So if I'm doing f plus g of x, it simply means to take function f of x and add it to function g of x. That's all that means. So that's going to equal 2x squared plus 2x, that's f of x, added to g of x, 5x plus 4. Now, I could on the test ask you to do f minus g or f times g even. So any one of the operations is fair game in this problem. So be careful that f of x is a binomial, g of x is a binomial. Make sure you put parentheses. If this were a minus sign, that minus would distribute. A plus sign doesn't, but just again, if it is a minus on the test, that might happen. So distribute is what would happen. So I get 2x squared plus 2x plus 5x plus 4, which comes out to 2x squared plus 7x plus 4. That's f plus g of x. The other thing I'm asked for here is f over g. So if I'm doing f over g of x, that's simply going to be function f 2x squared plus 2x over g of x, which is 5x plus 4. Simplify if possible. This is not simplifiable, so that's all I can do to that one. I suppose that's probably the easiest problem on the whole test, to be honest, if that's the case. If it were multiplication, though, just to give you an idea, if I ask for f times g of x, that would be 2x squared plus 2x being multiplied by 5x plus 4. Now you're looking at a binomial multiplication problem, so distributive property with FOIL. Make sure you do all four multiplications there to get the simplified answer. In this case, it's going to be 10x cubed plus 8x squared plus 10x squared plus 8x. Combine like terms there, so you get 10x cubed plus 18x squared plus 8x. I'm going to stick to polynomial functions, whatever I'm doing. So polynomials, it'll be of this variety, this level problem. Just be able to do all four operations. Be careful with parentheses that may exist in these problems if the functions themselves are binomials or two or more terms, I should say. Then you got to make sure that parentheses exist so that any distributive properties that need to occur do occur. Number 9, difference quotient. Okay, you do have to remember what a difference quotient is. I'm not going to give you this on the test, so it's just a matter of remembering the difference quotient is f of x plus h minus f of x all over h. F of x plus h is the only thing that you don't know. All right, f of x is the function, h is h. So if I start with f of x plus h, it's going to be, instead of x squared, it's going to be x plus h squared. Instead of 2x, it's going to be 2 times x plus h, and minus 1 stays minus 1. So x is squared, x plus h in parentheses squared. X is being multiplied by 2, x plus h in parentheses being multiplied by 2. Again, using parentheses as necessary, so we're substituting a single object for multiple objects. X plus h squared is just going to be the first thing squared, 2 times the two things multiplied together, the second thing squared. The same shortcut we've been using this whole year. Square the first, double the product, square the second. 2 times x plus h is plus 2x plus 2h, and then minus 1 is just minus 1. That's what f of x plus h looks like. Okay? To complete the difference quotient, it's minus f of x over h. So if I create this structure, f of x plus h goes in front. It's this entire expression. So x squared plus 2xh plus h squared plus 2x plus 2h minus 1. We're subtracting from it f of x. F of x is this whole expression, and I'm subtracting the whole expression. So once again, proper use of parentheses here. Minus the parentheses x squared plus 2x minus 1. And all that goes over the letter h because h just goes on the bottom. That's just part of the difference quotient. So, the thing to be cautious of here is that this minus distributes through. If I distribute that through, I'm going to get minus x squared minus 2x and plus 1. Still all over h, and still all this stuff in front. What should happen if you do everything right up to this point is everything not containing h in f of x plus h should have an opposite from f of x. So x squared minus x squared cancels. This has an h, this has an h, this doesn't. Plus 2x minus 2x cancels. This has an h, this doesn't. Minus 1 plus 1 cancels. So everything of f of x that exists in f of x plus h is going to be canceled by subtracting the f of x away. The leftover pieces all contain the letter h. So if I divide this and this and this and this all by h, I'm going to be left with, from this term, just 2x because the h disappears. From this term, plus h, because one of the h's disappears, the other one sticks around. From this, plus 2, because the h disappears. All that goes over 1. Over 1 doesn't have to be written, so 2x plus h plus 2 would be the difference quotient of x squared plus 2x minus 1. Number 10. Okay, I'm using the book's notation here for composite functions, f of g of x. The notation I recommended in class, which is a little bit more obvious as far as what you're supposed to do with it, is the f of g of x with the function notation look to it. And the trick to this, and it's not even a trick really, it's just following the rules of functional notation. G of x equals this expression. This g of x and 3x plus 1 are equivalent to one another. So if it says f of g of x, I could just easily say f of 3x plus 1. And f of 3x plus 1 simply means to go up to f of x, right here, change both of the x's into 3x plus 1s. Okay? X is being squared, I'm going to change x to 3x plus 1, so 3x plus 1 is going to be squared. X is being multiplied by 3, so 3x plus 1 is going to be multiplied by 3. Again, cautiously substituting. One object is getting replaced with multiple objects. One object is going to be surrounded in parentheses when the multiple pieces get substituted in. 3x plus 1, the quantity squared, again, is squaring a binomial. 3x times 3x is 9x squared. 3x times 1 is 3x, doubled is 6x. 1 times 1 is plus 1. Then this distributive property going on here, 3 times 3x is 9x, 3 times 1 is 3. And then what's left to do is to add like terms. 9x squared plus 15x plus 4 is what f of g of x is. I'm going to stick to polynomial functions, x's to powers. I probably won't go above x to the second power. We did learn Pascal's triangle, but I'm going to avoid powers bigger than 2 on the test just to save time. Number 11. I want to highlight something right now, because even though I put this on every test every year, I have people that round in the chart. I don't know why. I don't know why. It's one of those things that teenagers do that baffle me, but it says very clearly, I think it's going to be just like the chart's going to be there in big, bold print, dark letters with an exclamation point, even do not round answers in this chart. Okay, hopefully you aren't one of the ones that do that. But if you round answers in the chart, it will lead you to inaccurate answers. Okay, we're looking for exact accuracy in these problems. The more accurate you are, the better. So do not round anything. So this tells me the distance traveled by a ball rolling down a ramp is given by this function. T is the time in seconds after the ball is released. So T is time in seconds. S of T is the height, the distance traveled, S of T, and it's measured in feet. So S is distance, T is time. Distance is measured in feet, time is measured in seconds. If I do a slope, change in S over change in T, it's going to be feet per second, which is going to be velocities, which is exactly what we're looking for, average velocity for the following time intervals. Okay, these are time intervals, and the letter T is the time. So this is all about, right here, what T equals. These numbers. 3, 3, 3, 3.1, 3.01, and 3.001. Okay, so what they're asking us to find out is, if we know where the ball's at, the distance it's rolled after this much time. They're asking me how far does it roll and how much time does it take. That's what the question is about average velocity. How far it rolled, change in feet, over how long it took, change in seconds, gets me a velocity feet per second. To find the actual distances, I'm going to rely on my calculator because I'm evaluating a bunch of numbers there. I'm going to change T to X for the sake of my calculator's sanity, because that understands X is not T's. 3x squared plus 4x plus 10. Again, this chapter dealt with linear quadratic functions. We're going to stick to linear and quadratic functions for this problem. I've got my function entered correctly. I go to my table, and I'm going to enter those numbers 3, 3.1, 3.01, 3.001. And it gets me answers. These answers are rounded answers. To get the unrounded answers, I have to go over here and notice 49.022, 49.022003. That's the not rounding thing I'm talking about. So make sure you go over to the Y column and give me the unrounded versions of each of those numbers. So for 3, the answer is 49, unrounded. Next one down, 51.23. Again, notice the bottom is exactly the same as what's in the chart, 0.23, 0.23. Now I got 49.22 up here, but it's 49.2203 is what it really is. And finally, 49.022033. So to get the average velocities, what they're asking for in this problem, V bar from 3 to 3.1, it's asking what's the average velocity from time equals 3 to time equals 3.1. What they're asking me to find is the slope between these 2 points where time is 3 and time is 3.1. So 51.23 minus 49 over 3.1 minus 3. How far did it go? How long did it take? 51.23 minus 49 is 2.23 feet, and it took 0.1 seconds. That comes out to 22.3 feet per second. That's all they're asking you to do, find the slope. Second one, this one, 3 to 3.01. Now they're asking me what's the average velocity from 3 to 3.01, so from this point to that point. So 49.2203 minus 49 over 3.01 minus 3. That comes to 0.2203 on top over 0.01 on the bottom. Dividing, both decimal points move 2 spaces over. That comes out to 22.03 feet per second. It traveled that far, that many feet, in that many seconds. Divide it out, you get the average velocity. The final one they're asking me for, velocity from 3 to 3.001. What's the slope between those 2 points? So 49.022003 minus 49 over 3.001 minus 3. That comes out to 0.022003 over 0.001. You travel that many feet in that many seconds. Move both decimal points 3 spaces to the right, I end up with 22.003 feet per second. That's all that's asking you to do. Again, if you round, these two would have both come out to 22. I'm looking for the 22.3, 22.03, 22.003. Looking for that progression towards 22. None of the answers is 22. So that's what I'm looking for, and I will be exactly right or they're not right. So don't round, get the exact right answers. Don't round anything over here. Either give me the however many decimal places it goes out. It shouldn't be too many. That's what I'm looking for number 11. Finally, number 12. Test of an internet service provider showed the following download times in seconds for files of various sizes in kilobytes. On your sheet, it's got one long chart here. It didn't fit on my board, so I had to break it into 2 charts. So here's the first 6, and then that's the final 6. They want to find a linear regression model for this data. And they are specifically telling you it's linear regression, which is nice. You don't have to determine whether it's linear or quadratic. I'm going to go to my calculator. I'm going to open up stat mode, enter all my data. And I like to enter the x's first. I'm going to put size as x, time as y. So 10.5 and 12.9 and 15, 20, 60, 75, 110, 156, 163, 175, 200, 250. I go over to my second column, enter all my y coordinates, 0.2, 0.24, 0.27, 0.36, 1.09, 1.42, 2.01, 2.68, 2.87, 3.10, 3.64, and finally 4.61. Just an understanding of this data, just to give you, make sure we understand this. The size is in kilobytes, the download time is in seconds. So if we're trying to find the linear model here, letting size represent the x-coordinate, time represent the y-coordinate, that's what I'm doing here. So if the size of the file is 15 kilobytes, it took 0.27 seconds. 156 kilobytes took 2.68 seconds to download. Now, if I wasn't told it was linear, if it just says find a regression model, I would want to go to my stat plot, and my window for x would go from 0 to, let's say, 300. I want to make sure all my x's fit. My y's would go from 0 maybe to 5. So let's go from 0 to 300 on x, and I'll go at a 10 scale there. And we'll go from 0 up to 5 on y, and then maybe go to 1 scale there. Go to my y equals, clear out any equations I have, and I can go up to plot and turn it on. If I want to see what the plot looks like, I hit second y, so it says stat plot. You see it's going to be a scatter plot here for L1, L2, which is where everything is. If I go to graph, it's just going to give me a scatter of all the data, and the data looks to be linear. That tells me it's a linear regression model. So again, if it doesn't specify, it looks like a line, so we're going to do a line. If it looked like a parabola, we would do a quadratic regression. Once I get that data entered, I'm going to go to my stat again, and I want to go to calculate. And you can see here, linear regression, AX plus B. And what it wants is what lists, L1 and L2 are the lists, and I'm going to calculate it, hit enter, and it tells me AX plus B, the slope is 0.018024687. B is 5.00457444, E negative 4. Be careful that you read that carefully to make sure that you see that E negative 4. So if I'm writing the linear regression line here, again, size and time. So the x coordinate is size, and the y coordinate is time. if I'm using meaningful variables for these things, I would probably go with t equals 0.018 x, but instead of x I'm going to use s, plus 5.004574 e negative 4 is actually 0.0005. If you put 5 there, you're going to get wrong answers. So be careful that you watch that carefully. Chances are on the test will be something similar where the y-intercept is going to be really, really, really tiny, but it's going to look like this if you don't read the whole thing. So be careful of that. And there's my linear regression model. That's part A. Type your stuff in your calculator correctly, apply the linear regression stuff, and then you do that. So part B, oh, and one other thing you do to verify your linear regression model, just to be safe. If I were to graph that, so 0.018x plus 0.0005 graph, it should split the data pretty close. It's not going to be perfect, but it'll be close. As you can see, that point misses by a little bit, but these pretty much get chopped. And this one missed a little low, that was a little high, the rest of them seem to be right on the line. That's what it should look like. If you accidentally didn't see that times 10 to the negative 4th thing going on, and you thought it was 5.00 whatever, I think it was 44, something like that, hit graph, there's no line. So if you want to verify your answer, you should see that line split your data. If you don't, then you probably read something wrong. Go back and see it more clearly. Then it does say times 10 to the negative 4th. All right. For the second part of this, it says, using the linear model from part A, in other words, our answer from part A, find the expected download time necessary. So find the time. So find t for a file that's 899 kilobytes. So a size of 899. So what they're telling me is let s equal 899. How long is it going to take? So t equals 0.018 times 899 plus 0.0005. So 0.018 times 899 plus 0.0005 equals 16.18 seconds. Right. Notice that none of the data here got all the way up to 899. All we have data through is to 250, but we can make predictions on bigger data based on what happened with the smaller data. So that's what regression is all about, as we would have mentioned in class. So keep that in mind, that the problem on the test is going to be some sort of regression, either linear or quadratic. I'm going to show you how to do both, and you should be able to do both. If I tell you what it is, go with it. If I don't tell you what it is, use the graph itself to identify. Again, using a graphing technique, y equals, type the answer in to see that the graph actually hits the data properly would be helpful. And then you'll be expected to use that linear regression or quadratic regression, whichever it is on the test, in order to find something else out.